Hey everyone, welcome to this ACT Math review session. Today, we're going to break down key skills and strategies to help you tackle the math section with confidence. All right, let's talk strategy, because the ACT Math section isn't just about knowing math, it's about knowing how to take the test. You've got 60 minutes to answer 60 questions, which means time management is just as important as getting the right answers.
Strategy 1. Plugging in numbers. What's the trick? Sometimes, algebra problems can feel impossible. Too many variables, too much confusion. But there's a way to make them easier. Just pick a number and substitute it in. This works great for expressions and equations where you see x, y, or any other variable. How does it work? 1. Pick a number to replace the variable. Just avoid 0 and 1, since they can behave weirdly. 2. Solve the problem using that number. 3. Plug the same number into the answer choices and see which one works.
Example problem. We're going to solve the equation x plus 2 equals 3x for using a test-taking strategy called plugging in numbers. Instead of solving algebraically, we'll try different values for x from the answer choices to see which one works. Example problem. Solve for x in the equation x plus 2 equals 3x. 4. Step 1. Start with a middle answer. If we have multiple choice answers, we typically start with the middle value. But let's pretend we don't have answer choices here. Let's just test some reasonable values for x. Step 2. Plug in x equals 2. Let's try x equals 2 and substitute it into both sides of the equation. Left side, 2 plus 2 is equal to 4. Right side, 3, 2. 4 is equal to 6. 4 is equal to 2. Oh, 4 is not equal to 2. So x equals 2 is incorrect. Step 3. Try x equals 3. Left side, 3 plus 2 is equal to 5. Right side, 3, 3. 4 is equal to 9. 4 is equal to 5. Yes, 5 is equal to 5. So x equals 3 is the correct answer. Final answer, x equals 3. Why use plugging in numbers? This strategy is useful because it helps if you're unsure how to solve algebraically. It confirms the correct answer by direct substitution. It works great for equations where x values are reasonable to test. So, when you see an equation with answer choices, try plugging in numbers. It can save time and help avoid algebraic mistakes.
Strategy 2. Plugging in answer choices. Backsolving. What's the trick? Sometimes, solving for XXX is too much work. So why not just test the answers instead? Since ACT math questions are multiple choice, we can take a shortcut by working backwards. How does it work? 1. Start with answer choice B or C, since they're usually in the middle. 2. Plug it into the equation instead of solving. 3. If the number is too low, try a bigger one. If it's too high, try a smaller one.
Example problem. Instead of solving the equation algebraically, let's use a test-taking strategy called backsolving. This method is great when the answer choices are numbers, because we can plug them in and see which one works. Example problem. Solve for x in the equation 2x plus 5 is equal to 19. Step 1. Start with the middle answer. When using backsolving, start with the middle answer choice. Looking at our options, A, 5, B, 6, C, 7, D, 8. The middle is x equals 6. Let's plug in x equals 6. 2, 6, plus 5 is equal to 12 plus 5 is equal to 17. Oops, that's too low. We need 19. That means the correct answer must be bigger than 6. Step 2. Try the next highest answer. Now, let's test x equals 7. 2, 7, plus 5 is equal to 14 plus 5 is equal to 19. Boom, that works. Since we found the correct answer, we don't even need to check x equals 8. Final answer, C7. Why use backsolving? This strategy is super useful on multiple choice tests because it avoids tricky algebraic mistakes. It's faster for some equations. It guarantees a correct answer if done carefully. So, next time you see an equation with numerical answer choices, try backsolving.
Strategy 3. Estimation and approximation. All right, folks, let's talk about estimation and approximation. Now, if you're anything like me, you might look at some of these big numbers and feel a little overwhelmed. But guess what? Estimation is your friend here. Here's why this strategy works. It helps you handle complex calculations, especially with fractions, and rounding things off can make everything feel a lot simpler. This doesn't mean you're ignoring the exact answer, but you're simplifying the process to get close enough. Quick and dirty, but still right. How do we use it? 1. First, round those numbers to easier values. Take 198 and round it to 200, much simpler, right? 2. Now you can quickly eliminate answer choices that are way off. If a number is too high or low based on your estimation, you know it's not the right answer. 3. And of course, use mental math to get close. No calculators here, just using your brain.
All right, class. Let's use a smart estimation and approximation strategy to solve this multiplication problem quickly. No calculator needed. Example problem. What is 198 times 51 approximately? Step 1. Round the numbers. Instead of multiplying 198 by 51 directly, we round each number to something easier to work with. 198 is close to 200. 51 is close to 50. So we estimate the problem as 200 times 50. Step 2. Multiply the rounded numbers. Now, multiplying 200 by 50 is much simpler. 200 times 50 equals 10,000. Step 3. Adjust for the rounding. Since we rounded 198 up to 200, our estimate is slightly higher than the actual value. Since we rounded 51 down to 50, our estimate is slightly lower than the actual value. These small differences mean the real answer will be a little less than 10,000. Step 4. Choose the best answer. Looking at the answer choices. A. 10,000 too high. B. 9,000 slightly lower than 10,000. This looks best. C. 8,000 too low. D. 7,000 way too low. So the best estimate is B. 9,000. Why use estimation and approximation? Saves time. You don't have to do long multiplication. Helps eliminate wrong answers quickly. Great for mental math on the ACT. So next time you see a big multiplication problem, don't panic. Round, estimate, and pick the best answer.
Strategy 4. Recognizing patterns. Okay, next up, let's talk about patterns. Now, I know you're probably thinking, patterns? That sounds like math class from 20 years ago. But trust me, recognizing patterns is a huge time saver, especially on the ACT. Some questions are all about finding that repeating sequence or number pattern. When you spot one, instead of going through the full calculation, you can just apply the pattern and be done. Here's how you approach it. 1. Identify the pattern, whether it's in numbers or shapes. 2. Apply it and skip the long, drawn-out calculations. 3. Keep an eye out for cyclic repetition, when things start repeating at regular intervals.
All right, class. Let's look at this problem and use pattern recognition to find the answer quickly. Example problem. What is the 50th term in the pattern? 2, 4, 6, 8. Step 1. Recognize the pattern. Look at how the numbers are changing. 2, 4, 6, 8. Each term increases by 2. This tells us that the sequence follows a simple pattern. Each term equals 2n, where n is the term number. Step 2. Use the pattern formula. We need to find the 50th term, so we plug in n equals 50 into our formula. 2 times 50 is equal to 100. Step 3. Choose the correct answer. The 50th term is 100, so the correct answer is B, 100. Why does this work? Recognizing patterns saves time. You don't need to write out all 50 terms. The formula for an arithmetic sequence, when numbers increase by a constant amount, helps us jump straight to the answer. So, whenever you see a number pattern, find the rule and apply it.
Strategy 5. Using proportions and ratios. Now, let's talk about proportions and ratios. Many ACT problems love to throw these at you. Proportions are all about comparing two things that change in relation to each other, either directly or inversely. And once you know how to set it up, it's smooth sailing. Here's how you do it. 1. Set up your proportion. You'll often see something like A/B equals C/D. This just means two ratios are equal to each other. 2. Cross-multiply. This is the key move. You'll multiply across the equal sign to get rid of the fractions. 3. Then solve for the missing variable. It's just a simple equation at that point.
All right, class. Let's solve a real-world problem using proportions and ratios. This strategy works really well when we know two things are related and we want to figure out the missing value. Example problem. If 3 pencils cost $1.50, how much do 10 pencils cost? Step 1. Set up the proportion. To start, notice that the price per pencil is the same for any number of pencils. So, we can set up a proportion to find out the cost for 10 pencils. The proportion looks like this. 3 divided by 1.5 equals 10 divided by dx, where 3 represents the number of pencils we know the price for. 1.50 represents the cost for those 3 pencils. 10 represents the number of pencils we want to find the price for. X is the unknown cost for 10 pencils. Step 2. Cross-multiply. Now, we can cross-multiply to solve for x. This means multiplying the numbers diagonally. 3 times x equals 1.5 times 10. 3x equals 15. Step 3. Solve for x. Now, to isolate x, divide both sides of the equation by 3. X equals 15 divided by 3, which equals 5. Step 4. Choose the correct answer. So, the cost for 10 pencils is $5. The correct answer is C, $5. Why does this work? Proportions help us compare two quantities that are related, like price and quantity. Cross-multiplying allows us to solve for the unknown value quickly. This strategy is super useful for word problems involving ratios, rates, and scaling. So, the next time you see a question with two related quantities, try setting up a proportion to find the missing value.
Strategy 6. Eliminating wrong answers. All right, let's talk about eliminating wrong answers. We've all been there. You're running out of time, and you're stuck on a question. So, what do? You start crossing out the answers that obviously don't make sense. Time management becomes key here. Why is this strategy so useful? Well, you don't have to figure out the perfect answer to every question right away. Instead, you can quickly eliminate incorrect choices, making your chances of picking the right one higher. Here's how to use this strategy effectively. 1. First, identify choices that seem too high or too low. For example, if you're dealing with a problem where the answer should be around a specific range, get rid of options that are way off. 2. Check the signs, positive or negative, because that can quickly give you a clue about which answers don't fit. 3. Eliminate the extreme answers first. Extreme numbers that don't seem realistic are usually there to distract you.
All right, class. Let's use a strategy called eliminating wrong answers to estimate the square root of a number. This is a great strategy when you're not sure about the exact answer, but you can eliminate the choices that definitely don't work. Example problem. Which is the best estimate for square root 50? Step 1. Estimate using nearby perfect squares. We know that square root 49 equals 7, because 7 times 7 is equal to 49. Square root 36 equals 6, because 6 times 6 is equal to 36. Now, square root 50 is slightly larger than 49, so its square root will be just a little more than 7. Step 2. Eliminate clearly wrong answers. Let's go through the choices. A. 5 is definitely too small since 5 times 5 is equal to 25, which is much smaller than 50. B. 6 is too small because 6 times 6 is equal to 36, and 50 is larger than 36. D. 8 is too large because 8 times 8 is equal to 64, which is way bigger than 50. Step 3. Choose the best estimate. That leaves us with C7. We already know that square root 49 equals 7, and since square root 50 is just a little bit more than 49, the best estimate is 7. Answer: C7.
Strategy 7. Understanding word problems. Word problems can be tricky, but they don't have to be if you break them down systematically. The goal is to convert these word problems into math equations. Sounds like a puzzle, right? Here's how to approach them. 1. First, identify key numbers and relationships in the problem. This is where you'll find your clues. 2. Next, define variables. Let's say you're solving for someone's age, like Sarah in the coming sample question. You define a variable for Sarah and Jake's ages, then write an equation. 3. Finally, solve step by step. You don't have to rush. Just follow the logic one step at a time.
All right, class. Let's focus on understanding word problems and how to translate the words into an equation that we can solve. This strategy is super helpful for making sure you understand the situation before jumping into the math. Example problem. Sarah is 3 years older than twice Jake's age. If Jake is 5, how old is Sarah? Step 1. Break down the problem. First, let's look at the sentence and identify the important pieces of information. Sarah is 3 years older than twice Jake's age. This tells us that Sarah's age is 2 times Jake's age plus 3 years. So, we can write an equation. S equals 2J plus 3, where S is Sarah's age, J is Jake's age. Step 2. Plug in the known value. We know from the problem that Jake is 5 years old. So, substitute J equals 5 into the equation. S equals 2, 5 plus 3. Step 3. Solve the equation. Now let's simplify. S equals 10 plus 3. S equals 13. Answer, D, 13.
Strategy 8. Using the calculator wisely. The calculator is your friend on the ACT, but like any tool, it's important to use it wisely. Yes, you're allowed to use a graphing or scientific calculator, but that doesn't mean you should rely on it for everything. So, what's the trick here? Well, some problems are much faster if you do them by hand, like simple addition or subtraction. Don't waste precious time plugging in easy numbers. Here's how you should use your calculator effectively. 1. Use it for large calculations, fractions, and radicals. When the numbers get big or complicated, that's when the calculator really shines. 2. Avoid using it for simple arithmetic. You want to save your calculator time for the tricky stuff. 3. Check your final answer. After calculating, you should plug your answer back into the problem to make sure it makes sense.
All right, class. Let's use a very important strategy, using the calculator wisely, to solve a problem that involves subtraction of squares. Example problem. What is 7.3 squared minus 4.1 squared? Step 1. Recognize the difference of squares. First, notice that the problem involves the difference of squares. This means we have the form a squared minus b squared, which we can simplify using a special rule. A squared minus b squared equals a plus b, a minus b. This rule can save us time and make it easier to solve. Step 2. Apply the formula. Let's rewrite the expression using the formula. 7.3 squared minus 4.1 squared equals 7.3 plus 4.1. 7.3 minus 4.1. Now, let's do the addition and subtraction. 7.3 plus 4.1 is equal to 11.4. 7.3 minus 4.1 is equal to 3.2. So now the problem is 11.4 by 3.2. Step 3. Use the calculator. Now we can simply multiply 11.4 and 3.2 using the calculator. 11.4 times 3.2 is equal to 40.16. Answer, B, 40.16. Why does this work? Instead of calculating 7.3 squared and 4.1 squared separately, and then subtracting, we use the difference of squares formula to simplify the problem. Using the calculator wisely means not only plugging numbers into it, but also recognizing when you can simplify the problem first to save time and effort. By applying the formula and doing the multiplication, we got the correct answer without needing to square the numbers individually. So, remember, recognizing patterns like the difference of squares can help you use the calculator more efficiently and solve problems faster.
Strategy 9. Knowing when to skip and come back. Time is of the essence, and sometimes the best strategy is to not waste time. Every question is worth the same amount, so getting stuck on a tough problem could cost you time for easier ones. Here's how to handle that. 1. If a problem is taking more than 60 seconds, just skip it. Seriously, don't get caught in a time trap. 2. Circle the question number so you can come back to it later if you have time. 3. Always fill in an answer before time runs out, even if you have to guess.
Let's look at a scenario. If a problem involves 3 unknown variables and no obvious starting point, should you? A. Try solving immediately. B. Guess and move on. C. Skip and return later. D. Eliminate choices and estimate. In this case, the best move is to skip and return later. So, the answer is C.
Final tips and recap. Before we wrap up, here are some final tips for success. 1. Practice timing. 60 questions in 60 minutes means 1 minute per question. It's important to get used to pacing yourself. 2. Memorize common formulas like the Pythagorean theorem or basic area and perimeter formulas. Having these at the ready can save you time. 3. Take practice tests under time conditions to get used to the test's rhythm. 4. Use strategies together. For example, combining plugging in values with elimination can save you time and improve your accuracy.